Hello everyone, good morning. Welcome to my channel Ma. So in this video we'll discuss a theorem of total probability. Okay, so probability distribution mathematics 3. In unit 1 we have two theorems proofs. One is binomial, one is Bayes theorem, and the second one is theorem of total probability. This one also is asking in some previous year question papers. Ma. So see the definition here. Let E1, E2, so on, En are partitions of a sample space S, and for all I is equal to 1 to n, P of Ei is what? Greater than 0. Probability of any experiment is always greater than 0. But please stop. Let A be any event associated with S. A is any event associated with S, sample space S, then probability of A is what? P of E1 into P of A by E1 plus P of E2 into P of A by E2 plus so on plus P of En into P of A by En. Okay, is nothing but summation I is equal to 1 to n P of Ei into P of A by Ei. That is the definition of theorem of total probability. Sometimes he will ask you define theorem of total probability. Also, he will ask you for 2 marks. Then you have to write till here. Okay. Then what is the proof, ma? So first one, what he gave here, E1, E2, so on, En are partitions. Then Ei intersection Ej is what? 5. So and E1 union, E2 union, so on, union En all are including sample space. Yes. Okay. Now what is A here? A is A and S. Correct. A and A intersection S is A. So therefore, in place of S, what you have to write? E1 union, E2 union, so on, union En you have to write. Then change the intersection mark. If you take intersection, then it will be A intersection E1 union A intersection E2 and union so on A intersection N. Then both take probability. So if you take probability P of A union will become addition. P of A union B, P of A plus P of B, that's the thing formula. So P of A intersection E1 plus P of A intersection E2 plus so on plus P of A intersection En. So P of A intersection E1 is what? By conditional probability. So P of A intersection E1 can be written as P of E1 into P of A by E1 plus P of A intersection E2 can be written as P of E2 into P of A by E2 plus so on plus P of En into P of A by En. Okay, so this is nothing but this is the part of Bayes theorem denominator, ma. Bayes theorem denominator. Okay, so it's a simple theorem and the proof also very small. Just to go through it, it will take hardly some 5 to 10 minutes to go through this theorem proof, so that it will be useful to if it will come in the exam, you attempt it. Otherwise it will be keep it in the book and all. Okay, thank you.